So welcome students. So in this question, you're given the function f of x is equal to x power 10 plus x square plus 1 by x square plus 1 by 1 plus secant inverse x. And you're asked to find the minimum value of this expression. So let us try to analyze this function. First, what is the domain of this function? So the domain of this function is this terms are defined for all x except 0. So 0 is a problematic part, and secant inverse of x is defined for all numbers outside minus 1 and plus 1. So minus 1 to plus 1 is the problematic part. Open minus 1 to plus 1 is the problematic part. So 0 is already included here. So effectively, minus 1 to 1 numbers cannot be placed in the place of x. So the domain of this function is either minus infinity to minus 1 or 1 comma infinity. Now, to find the minimum value of this expression, let us analyze these two expressions separately. Let us try to analyze these two expressions separately. Now, what about this expression? Let this be sum h of x. X power 10 plus x square plus 1 by x power 12. Now, what is the differentiation of this? To analyze maxima and minima, let me do the differentiation of this. That is equal to 10 times x power 9 plus 2 times x minus 12 by x power 13, right? Minus 12 by x power 13. Now, let us analyze in these two intervals. The first thing that I need to do is, the first thing that I see is this is an even function. This is an even function. That means if I know the graph on the positive side, the graph on the negative side will be just the mirror image with respect to y-axis. Now, if you see, if x is greater than or equal to 1, so this number, the x power 9 will be greater than 1, x is greater than 1, so this combinedly will be greater than 12. And if denominator is 1 or greater than 1, this number will be less than 12. So a number greater than 12 minus a number less than 12 will always be positive. That means h dash of x is always greater than 0 when x is less than 1. When x is greater than or equal to 1, this implies h of x is an increasing function. H of x is an increasing function. So how does the graph of this look like? That means if I draw the graph of this, so I'm only looking after 1 and before minus 1. At exactly x is equal to 1, the value of this is equal to 3. At exactly x is equal to 1, the value is equal to 3. And after this, the graph is an increasing function. That means the value is increasing. Similarly, because it's an even function, I can just flip the graph here. So what is the graph on the negative side? The graph on the negative side will be something like this. So that means what is the minimum value of this expression h of x? The minimum value of this expression h of x is equal to 3, and it occurs at minus 1 and plus 1. Next, so let us try to analyze g of x is equal to 1 by 1 plus secant inverse x. So how does the graph of secant inverse x look like? So you know the graph of secant inverse x. So the graph of secant inverse x looks like this. It does not lie between 1 and minus 1. The domain is excluded. And the range is 0 to pi. So you have a pi by 2 here. So if a positive numbers goes inside secant inverse, you get angles in the first quadrant. If negative numbers goes inside secant inverse, you get the angles in the second quadrant. So you have a graph which is like this, because secant inverse of pi by 2 is not defined, and you have a graph like this. So next, let us try to analyze the function g of x is equal to 1 by 1 plus secant inverse x. Now, let me not draw the graph of this. Let me analyze this analytically. Now, I want the minimum value of this effective function, and the minimum value of this function turned out to be 3, and it is happening at x is equal to plus or minus 1. Now, what is the minimum value of this expression? So this expression will be minimum if the denominator is maximum. And 1 plus secant inverse x will be maximum if secant inverse x is maximum. And what is the maximum value of secant inverse x? So the maximum of secant inverse x is nothing but pi, right? Because the range of secant inverse is 0 to pi. So the maximum value of secant inverse is pi, and it occurs at x is equal to minus 1. So the maximum value of secant inverse x is equal to pi, and it occurs at x is equal to minus 1. So what is the maximum value of 1 plus secant inverse x? 1 plus pi. And what is the minimum value of g of x? G of x minimum is equal to 1 by 1 plus pi, and it occurs at x is equal to minus 1. So we are lucky because at x is equal to minus 1, my first function is also minimum. At x is equal to minus 1, this function is also minimum. So where does the sum of these two become minimum? So sum of these two become minimum when this and this are simultaneously minimum. And both occur at same point. Luckily, if they occur at different points, I need to analyze them separately. So this also has a minimum at x is equal to minus 1. This function also has a minimum at x is equal to minus 1. So if you want the effective minimum, I can just substitute x is equal to minus 1. So effective minimum comes when x is equal to minus 1, not plus 1. So if you substitute x is equal to minus 1, the minimum value is nothing but, you get 3 here, plus 1 by 1 plus pi. That is equal to 3 plus 3 pi plus 1 by 1 plus pi. That is equal to 4 plus 3 pi by 1 plus pi. So that will be the minimum value of this effective function f of x. Thank you.